Okay, this is for Honor Geometry, Chapter 1, Section 1.5, Postulate, Theorems, and Relating Points, Lines, and Planes. Okay, so this is the last section of Chapter 1. Objective for 1.5 is use postulate, postulates, and theorems. We are going to learn first theorems. Relating points, lines, and planes. Okay, so we are going to learn new postulates and theorems, and we will learn how to use them. Okay, so far we learned 4 postulates. So those are Ruler postulate. This is that between any 2 points, you can measure the distance between 2 points by putting some kind of measurement unit next to it, or assigning a value to the points on the number line. And then segment addition postulate. This is if 3 points are collinear, this plus this equal this in terms of distance. Then protractor postulate. Protractor postulate. This is the same thing as this, but the measure of angle version. So by attaching some kind of unit measurement like protractor next to it, you can measure any angles. And angle addition postulate. Again, if you have this measurement and this measurement, if you add these together, you get this. So for this one, this point here have to be interior of this angle. And for this one, these 3 points have to be collinear. And both of these, you can only add the lengths. You cannot add the geometric figures. So you have to use this. In this case, this is AB plus BC equal BC, but not AB plus BC equal, I'm sorry, this is AC. You can do this, right? You cannot add the segments, you can only add the numbers or the distances. And same thing here, you have to put M. So if this is O, A, B, C, measure of angle ABC plus measure of angle BOC, I'm sorry, not ABC, AOC, AOB plus BOC equal measure of angle AOC. And you need this M. Okay, so those are the 4 postulates we learned so far. And here are 5 more postulates, and then you have 3 new theorems. The theorems are proven using these postulates. Okay, and the postulates are spelled out here. We actually already learned them conceptually. These are just spelled out here as a postulate, but we learned already. So these are: a line contains at least 2 points. A plane contains at least 3 points. Not all in one line. So the 3 non-collinear points determine the plane. 2 points determine the line. And the space contains at least 4 points, not all in the same plane. We haven't done this one, but it makes sense. You need 3 non-collinear points to determine the plane, and then if you have another point not on the plane, that determines a plane space. But we really don't use this in our textbook or in our programs. Okay, next one. Through any 2 points, there is exactly 1 line. We also talked about this. It makes sense. You can only draw 1 line between 2 points. Through any 3 points, that is there is at least 1 plane. At least means it could be more than 1. Through any 3 points, there are at least 1 plane. It could be just 1 or infinite. And through any 3 non-collinear points, there is exactly 1 plane. So we already talked about this. So this is just spelled out. Exactly 1 is the same as 1 and only 1, meaning that the plane exists and the plane is unique. There are a couple examples that you have to rephrase these postulates in one of these So exactly one, and one and only one, and exist, and it exists, and it is unique, are saying all the same thing. Or also, you can also say determine. Okay, the three non-collinear points determine the plane. These are all saying the same thing, meaning that there is only one. Okay, if 2 points are in the plane, then the line that contains the points is in that plane. If 2 points are in the plane, then the line that contains the points is in the plane. This is what it means. This we didn't really talk about this, but think about it. Do you remember I said the line can only either touch infinitely or touch only once, right? Either intersecting and therefore touching only once, or it's in the plane and therefore it's touching an infinite points. You cannot touch just 2 points and then not touch other points, because then otherwise it won't be line. It will be something like this, like, you know, curved something for it to be touched only twice. So any line have to either touch once or infinite numbers. So what it's saying is that if there are 2 points touching on the plane, then the whole line have to be in the plane. That's what this is. By the way, any of these, if it doesn't make sense, you ask me in school and then we go over it. Okay, this is kind of like a preview. Okay, all right. And postulate 9: if 2 planes intersect, you know, just to put the circle next to it or something when it doesn't make sense to you, and then you ask me. If 2 planes intersect, then their intersection is a line. Wait, if 2 planes intersect, then their intersection is a line. We already did this, right? The two, well, now it's a postulate, but we talked about this. 2 planes can only intersect as a line. It cannot intersect as a point because the plane is continuing without any ends. Okay, so those are the 5 postulates, and then here are the 3 theorems that you can prove by using these. If you can prove, it's better, and therefore the theorems are considered to be higher standard mathematically than postulates. The mathematicians try to eliminate all the postulates if they can by proving the postulates that they had to accept. Okay, so if 2 lines intersect, then they intersect in exactly 1 point. Okay, so if 2 lines intersect, it can only intersect once. If they were to intersect twice, you have to draw like this, but then that violates the point that through any 2 points there is exactly 1 line, right? So 2 lines can intersect only once. Through a line and a point not in a line, there is exactly 1 plane. So through a line, there are infinite points on that plane. If there is another point not on the line, over here, 2 points determine a line, right? Doesn't matter how many are here. If there is a line, then there are at least 2 different points. If there's only 1 point, then that's not a line. For there to be a line, there have to be at least 2 points. And if there is a third point not on that line, meaning it's non-collinear, that have to determine the plane. So through a line that guarantees that there are at least 2 points, and the line not on the same line, so that's a non-collinear point, exactly 1 plane, determine a plane. Okay, and theorem 1.3, if 2 lines intersect, then exactly 1 plane contains the lines. Okay, so if here's 1 line, okay, and so that means that there are at least two points on the line. It's guaranteed. If there's a line, there have to be 2 lines. Here's another line intersecting. The fact that another line intersected, it guarantees that there is 1 point here, there's at least 1 point here by intersecting. That's a collinear, so that doesn't help. The fact that this is a line, there have to be another point that is not identical to this one somewhere on this line, right? That introduces the non-collinear third point. So if the 2 lines intersect, those lines have to be coplanar. Okay, so that's this one. All right, so that's it for this packet in terms of new concept. I want to do a couple of these in the video, and then so I'm gonna go over how about 8, 10, and 12, and then you do these for the video survey. Okay, these are survey problems. Okay, so this one, not only these, we actually had these on the test already, most of these, but now you have to find which postulate guarantees that this is true or not. Okay, so state a postulate or part of a postulate that justifies the answer to each exercise. Okay, so let's look at A. Name 2 points that determine line L. So line L is this one, and we have C and A. So now we look at 2 points. So 2 points, these 2 points are determining a line. So let's look at the list of the postulates and lines and which one would give us that. And here is through any 2 planes, through any 2 points, there is exactly one line. Exactly one line is the same as determine a line. Okay, so that's postulate 6. Where are we? Okay, so this is postulate 6. Name the intersection of plane M and N. So that is line AB. Plane M and M intersecting line AB, and then that is if 2 planes intersect, their intersection is a line. So that's postulate 9. This is C and A. All right, 12. Does plane N contain any points not on AB? Does plane N contain any points not on AB? The fact that this is a plane, it have to have a third point that is non-collinear to this. So answer is yes. Have to contain, the fact that this is a plane, it have to contain another point that is not collinear to this. So which one is that one? Through any 3 points, there is at least one plane, and through any 3 non-collinear points, there is exactly one plane. So that's postulate 7. Okay. All right. So you are doing these for the survey. Okay.